let's start with this problem. So the integral of x cubed square root of x squared minus 3. Okay, cool. Is this the one that we were asking? I think this is the one you're talking about. My fault. I just realized I put up the wrong thing. So, okay. So what we're going to start with on this is a u substitution. And it's not entirely clear at first maybe that u sub is going to work. But if you let u equal x squared minus 3, which I think is the only thing that would make any sense for u sub, right? So, like, because that's in the inside of the square root. Then du is 2x dx. And so we have to go about trying to create the du at the end of the problem. So I'm going to get the x from this x cubed. So I'm going to move the x over next to the dx. And so there's 3 of them there, which means I'm going to have 2 left. And I get it set up like that. Does that make sense to everybody? All right, and now I need 2x dx. So I'm going to multiply inside by 2 and outside by 1/2. But now because I put that 2 there, I need that 1/2 outside. And so the thing that's weird is you have that x squared outside of the square root that doesn't really match the rest of what's there. But if you solve this original u sub equation for x squared, we can see that x squared is u plus 3, which is weird, but does that make sense to everybody? That's good. All right, and so then I can replace x squared with u plus 3. And then instead of the square root of x squared minus 3, that's the square root of u. And then I've got du. And now that's a doable integral because you can distribute the square root of u. To distribute that, you want to think of it as u to the 1/2, I think, just because it's a little bit easier to deal with that way. So then if I distribute it, I get u to the 3/2 plus 3 u to the 1/2 du. Does that make sense to everybody? Any questions? And now we're going to split that into 2 problems. The 1/2 is going to go onto both of them. So I'm going to get 1/2 integral u to the 3/2 du plus, and then on this one, I'm going to pull the 3 out. So it's 3/2 integral u to the 1/2 du. And now I use the power rule on both of those. So I get 1/2 times 1 over 5/2 u to the 5/2 plus 3/2 times 1 over 3/2 u to the 3/2 plus c. And now let's take a second to simplify the fraction. So 1/2 times 2/5 u to the 5/2 plus, and then here it's 3/2 times 2/3, which actually ends up canceling, u to the 3/2 plus c. So these cancel completely. And then here the 2's cancel, so we get 1/5. And then instead of u to the 5/2, we've got x squared minus 3 to the 5/2 plus, and instead of u to the 3/2, we have x squared minus 3 to the 3/2 plus c, and then that's the answer of this problem. That makes sense? All right. Any questions? So if there's anything that doesn't make sense, yeah, no problem. Any questions at all from anybody on this? Anything that doesn't make sense, don't feel bad about that. That's the point. You guys have a test as early as 4 hours from now, so, or you could wait till tomorrow night, whatever you want, but you can take it. You got a test, so you got to know how to do this. So feel free to ask if you're not sure on something. All right, no panicking. You can also wait 24 hours from now if you want. All right. Other stuff. So I'm going to let you guys ask the questions. It can be, can you do this problem from this exam? Or here's this 4-hour gang. All right, Andrew, so you're going to take it here in 4 hours. That's fine with me. Anyway, I'll let you guys ask, but you can pick out a problem. You can tell me what it is. You can unmute yourself and ask. That's fine. Or you can say, hey, can we do one that involves U sub with E or something, you know, whatever you want. A trig identity integral, good. Somebody asked that earlier and we ran out of time for that. Same problem where you have to change the bounds when switching from X to Y.
Can I ask like a frivolous question really quick?
You can, yes, of course.
So I always forget to put the plus C, and
Yeah.
it's bound to happen on a problem on the test.
Yeah.
Unless
WebAssign's going to count it wrong.
How many points, like what percent?
WebAssign is going to count it wrong. Like, they're going to count it wrong.
Oh, no.
You are going to then tell me, and my opinion is that you should not lose any points for that unless you're doing it a lot.
Okay.
Does that make sense? And
yeah,
so,
you on a post-it.
Now, not everyone in here is in my lecture, so it's somewhat up to the instructor. You for sure should not lose full credit for that, but you might lose a point. So anyway, WebAssign will count it wrong, and then probably my rule will be that I will be glad to make corrections on your exam, but you have to meet with me while we do it. Does that make sense? So
yeah.
Because I have like 85 students in Calc 2, I cannot get an email and say, hey, Doug, can you check problem 7, 9, and 11? You just got to sit with me and do it right after class, or we got to set up a quick meeting. And it doesn't have to be like Friday. In fact, it cannot be Friday because you need to take a break and so do I. But we can do that type of correction like next week. Does that sound good? Or even 2 weeks from now? Yeah, no problem. No problem. That's a good question. Somebody else, I am going to get to these problems. Somebody else in the chat is asking, will it be average value? No. So the cutoff is area volume. Average value and arc length are topics on the schedule for this week, but will be covered on exam 2, not exam 1. Okay, so the last stuff will be the volume. Yeah, no problem. Okay, so we're going to do one involving a trig identity. So I'm going to put this problem up. And so trig identity integrals, man, they're really annoying because a couple of reasons. One is x to u. Okay, yeah, Clayton, I think I know what you mean. You're talking about like a definite integral, right? Like if it's like from 2 to 4 and you have to change them. Yeah, we'll do that next. Okay, so the trig identity ones, they're hard because for 2 big reasons, and I talk about this in videos, or I talked about it in live lecture whenever we were doing this, but it's hard because none of us, including me, no matter how much I like trig, like none of us are as used to using trig identities as we are like algebra. Like everybody knows, okay, x squared times x cubed, you make that x to the 5, things like that. So algebra, we're all used to doing the stuff with that. Trig, we're not as used to those things, and you don't always do the same thing. So like in algebra, if you're writing x squared times x to the 4th, you're almost for sure going to make that x to the 6th. The weirdest thing you might ever do with algebra is basically what we did back here, where you split up x cubed into x squared times x. And that's weird. You had to be creative, but like that algebra is not that hard. And so you do pretty much the same thing every time, and it's rules that everybody's used to. Trig, the rules, nobody's used to them, or at least not as used to them as they are algebra. And then you don't always do the same thing. Like sometimes it's a good idea to write it as sine and cosine. Sometimes that's not a good idea. It just depends. And then what makes it worse is the problems themselves, the forms are weird. So like the easy forms for trig are, okay, sine and cosine, which would make sense. Those are easy. But then secant squared's easy, and cosecant squared's easy, but secant is hard, and cosecant is hard, and secant tangent is easy, and cosecant cotangent is easy, meaning those are basic forms, but like cosecant by itself or cotangent by itself, those are not as easy. And it's not like they're impossible, but it's not just you have a formula. And so like, we're not as used to messing with it. We are matching these 4 weird forms. These 2 would make more sense, but these 4 are real weird. And so you just have to be able to mess with it. And so if you do see one like this, be willing to start it over if you're not getting anywhere. And so this is a problem where a lot of people would write it as sine over cosine. And I think you can get it to work that way, but it's a lot harder. And the identity that you want to end up using here is the identity that 1 plus secant squared, or I'm sorry, 1 plus tangent squared is secant squared. So we know that 1 plus tangent squared x is secant squared x, which means I can rewrite this as secant squared x minus 1. And that's a good idea here, first of all, because it's true, but second of all, because now secant squared is easy. So like that's a form we know how to do. So that's why that's a smart move. It's not always a smart move. It's not always what you'd want to do, but it's what you want to do here. So like now we can split this into the integral of secant squared x dx minus the integral of 1 dx. Well, then, okay, that's tangent x minus x plus c. And once you know to do this, it's not that hard. There is not a good way to look at that and know immediately what to do at all. So if you just make one up, I may not know how to start it. It may not be possible, but like the more you do, kind of the better you get at it. There are some practice problems like that, mostly in the very beginning handouts. So basic antiderivatives 2 is the worksheet. And you have answers, but probably not solutions to that set. So basic antiderivatives 2, you have the answers to that, so you can check it. But there's a bunch of them where you have to mess with identities, and so it's just a matter of messing with them, trying to get them to match. Remember that all the problems we're going to do tomorrow, you can do either using basic forms or with U substitution. Nothing more advanced tomorrow, so you don't need parts. You don't need any other technique that we're going to learn later. So you're able to do them. So if you're not getting anywhere with it, scrap it, go do the other problems, and come back. Does that make sense? So you just have to kind of mess with it and see. Sometimes they're tricky. Somebody asked in the chat, is there a good place to find all of the identities you need to know for the exam? If you find, if you Google Trig Identity formula sheet, I'm sure there's some good ones that would come up. The main ones that would be useful, I mean, so you guys are in Calc 2, technically anything from Trig is fair game. In a practical sense, the ones that typically come up are called the reciprocal identities, the quotient identities, the Pythagorean identities, the double angle formulas, and the half angle formulas. It's unlikely that you will have to use anything more advanced than these first 3 on tomorrow's exam. Later, we will do more trig integrals where you will use some of these. There are other trig identities that you were supposed to learn in trig or pre-calc. Chances of that showing up in an exam are not good. Does that make sense? Somebody in the chat asks, will we be dealing with integrals like secant cubed, tangent cubed? Not yet. So that will be a topic that'll actually be covered in class next week, powers of secant and tangent. And so that will be pushed to the next exam, okay? 6A from the same exam. Yes, we can, but somebody wants to do one with U sub and a definite integral. So if this is one of those, we will do it. And if not, we will do this after that one. So we will do this after that one. So we will do one definite integral with U sub, and then we will go to 6A from that same exam. All right, any other questions before we move on from the trig stuff? This is, I don't know if it's the hardest or easiest trig one. It's just whether you see that. It's easy once you see it, and it's not if you don't see it. Sorry. I wish I had a better way to explain that. All right, any other questions so far? All right, sounds good. And the trig identities, does that help with whoever was asking for that? Sorry, I'm not like writing them out, but if you Google that, you can find it. Remember, you guys can use any printed notes you want. So if you have a printer, you can just print one out. If somebody has a good one, if you know where one is, feel free to put the link in the chat so people can get to it. I don't have a good one to right now. I should probably look for one. 16 questions on the exam. All right. All right, so let's do this problem. Let's do the integral of x, or no, let's do 5 square root of 2x plus 1 dx from 0 to 4. All right, so let's look at that problem. We're going to do a U substitution on that, even though it's not like real complicated U substitution. There are 2 good ways to show this. And so the notation is actually important. And what I would recommend that you do is I would recommend that you do the U substitution work on the side. So I would come over and say, okay, we're going to let U equal 2x plus 1. Du then is 2dx. So I'm going to pull the 5 out, multiply by half outside, and 2 inside, and rewrite this as u to the 1/2 du. And I would make it clear, if you're showing your work, which you are, that you know this is not equal to this, okay? And so now this is 5/2 times 1/3/2 u to the 3/2 plus c. That's then 5/3 times 2x plus 1 to the 3/2 plus c. Now, that's the indefinite integral or antiderivative. And so then when you're back to the main problem, you would say, okay, well, then this is that answer with any c value that you want. So if you'd like c to be 39, you can put plus 39. If you want c to be negative pi, you can put minus pi. Normally we pick c to be 0, so you just don't put anything for c over here. And so now you plug in the 4, plug in the 0, and subtract. And if I plug in 4, I get 9 to the 3/2. If I plug in 0, I get 0 to the 3/2. I'm sorry, I get 1 to the 3/2. But that's important that when you plug in the 0, you don't necessarily get 0, so double check that. 9 to the 3/2 is 27, so without a calculator, that is the square root of 9 to the 3rd, which is then 27. So we get 108/3 minus 5/3. 108 times 5, actually, 27. I think that's right. 27 times 5. Somebody want to double check me? That's not right. That's 135. Man, I'm struggling. 135. So we get 130/3, unless I multiplied wrong again, but I think that's right, 130/3. Does that make sense to everybody to do it that way? I'm going to also quickly show how to do it while changing the bounds. This is what the actual question was, but I think this is the easiest way to show this. Yeah. Okay. So if we're doing the same problem, 0 to 4 of 5 square root 2x plus 1. The other option is to rewrite the problem with u simultaneously as when we're doing the definite integral. So we're going to leave the 0 and 4 there for now. We go about doing the u substitution, so we pull the 5 out, multiply by 1/2 outside, put this here, and then 2 dx here, and we keep it 0 to 4. And now something changes. So when you're doing a definite integral, the dx tells you that, yeah, okay, 1 second, I'll answer these questions in chat. But when you're doing a definite integral, the dx tells you that these are x's. Does that make sense? Okay, and so these are still x's. But now when we change to du, these are u values. So this is going to be 9, and that's going to be 1, because when x is 4, u is 2 times 4 plus 1, which is 9. When x is 0, u is 2 times 0 plus 1, which is 1. So you plug those in there to get the 1 and the 9. Does that make sense? All right, now we do the integral like normal, and so we do 1/3/2 u to the 3/2 from 1 to 9, but because those are u values, you do not go back to x. So you might simplify this and make it like 2/3 u to the 3/2. but now you plug in 9 and 1 and subtract. And so you get 2/3 times 9 to the 3/2 minus 2/3 times 1 to the 3/2. And now you do your work and you get the same thing we got up there, which I hope is 130/3. Does that make sense to everybody? Okay, and so this is faster, but it's a little bit easier to mess up. And by a little bit easier to mess up, I think it's a lot easier to mess up. So the reason I think it's a lot easier to mess up is that people get very used to going back to X, which is really good. You should go back to X. But what people tend to do is they might remember to make these 1 and 9, but then they keep these as 1 and 9 and sometimes go back to X here, and you shouldn't, because these are U values. To avoid that confusion, I would recommend doing this, where you go over and you just compartmentalize it. So what the fundamental theorem of calculus says is, as long as this is continuous from 0 to 4, you just need to find an antiderivative and then you can plug in the numbers. Well, okay, so then go over to the side and do all your work to find your antiderivative. And so that could be real easy or real hard. It could be whatever you need to do. And then go to the antiderivative and plug the numbers in from there. And your first step is the answer that you got over here. Does that make sense? Okay, but either method is allowed. And that's it. Okay, so I'm going to look in the chat for just a second. Yeah, sure. Okay, so can you always move whole numbers to the outside of the integral side? So you can factor out constant multiples. It doesn't have to be a whole number, but if it's like 5 times something, yes, you can pull the 5 out. Or if it's 2/3 times something, you can pull it out. Not if it's adding and subtracting, but if it's multiplication and it's just a whole number, you can do, or if it's just a number, you can do that. Second last problem. Zach, which problem are you talking about? This? Okay, just making sure. If you need to see something later, just stick around after and I'll show you whatever you need. Okay, other questions so far? I think I got everything in the chat about this problem. Is there anything else I'm missing? If I am, just send it again. I'm happy to answer it. All right. And double check me, that's actually 130/3. I might have multiplied wrong. Okay, any other questions on the definite integral stuff? Okay, and so somebody was asking for 6A on the exam, but then I think the same person said, instead, could we do a problem where you find the volume of curves and then take the definite integral? Is that not what 6A is? Let's actually do that for 6A. So, okay, so 6A on this exam says the region bounded by y equals x squared plus 1 and y equals 3 minus x squared revolved about y equals -2. And what this problem had said was just set it up. And we'll go ahead and evaluate it because I want us to be able to evaluate these two. And that's what that other question was in the chat. So there's some language above this: sketch the region and set up the integral for the volume of the solid. Anyway, so it's this region revolved about y equals -2. So let's get a sketch real fast. So the sketch, y equals x squared plus 1, looks about like that. Y equals 3 minus x squared looks about like this. Picture purposely not to scale. So this is 1 and this is 3. And now we need the boundaries. So we're going to set x squared plus 1 equal to 3 minus x squared. I'm going to add x squared, subtract 1. So then x is plus or minus 1. That means that this is at 1, 2, and -1, 2, and I'm getting the y values by plugging 1 into actually both of those. Either way, I should get 2. All right, any questions on how to get that diagram set up? Okay. And so then we pick a rectangle that at this point we should be able to quickly see should probably go up and down. And the base of that rectangle should be dx. And so now all of that is based just on this region. So we find the overlapping part of the region, we pick the rectangle, we label all the boundaries. So the bottom, the top, the left, and the right. And now, because it's dx, we want to solve every equation for the other variable. So if it's dx, you should solve everything for y. If it's dy, you should solve everything for x. Well, here, luckily, this problem is already solved for y. But if it weren't, we should do that. We should know that this one then is y equals 3 minus x squared, and that this one is y equals x squared plus 1. Any questions on how to get that set up? All good? Okay. Okay, so then if we're revolving about y equals -2, y equals -2 is down here somewhere. And so we think of this rectangle, if we think of that rectangle as being vertical and the line is horizontal, we think of that as being perpendicular to those. So we're going to use the dishwasher method, where we have a big R and a small r. And they're both functions of x. So big R is the distance from the farther end of the rectangle to this line. So it's the distance from here to here. So you take the top y minus the bottom y. The top y is 3 minus x squared. The bottom y is -2. So we get -x squared plus 5 when we simplify that. Small r is the distance from the closer end of the rectangle to the line, that's this bottom part, to this line. So top y there. Yeah, we'll do one in terms of y in a few minutes. Maybe not exactly this one, but yeah, let's do one in terms of y in just a few minutes. So we'll take the top y minus the bottom y. The top y is x squared plus 1. The bottom y is -2. So we get x squared plus 3. Does that make sense? Any questions? All right, so then the volume is going to be pi integral big R squared minus little r squared dx, and it's going to go from -1 to 1 because we want to use all the x's in the region. Now, I know somebody wants to evaluate this, which we will next, but is everybody clear how to get that set up? Any questions on the setup? All good? Okay. And so now to evaluate that, I think this problem did not ask us to evaluate that, but if we were to evaluate that, what we should do is square both of those binomials. So we would go x to the 4th minus 10 x squared plus 25. That's what you get. So if you're not sure how to do that, shortcut, you would write -x squared plus 5 times -x squared plus 5 and like FOIL that out or distribute that out. Does that make sense? Okay, the question in the chat real quick, how do you know when to have pi or 2 pi? So yeah, so pi is the dishwasher method, 2 pi is the shell method. So dishwasher, the formula is pi integral big R squared minus little r squared dx or dy. The shell method is 2 pi integral RH and then either dx or dy. All right. Okay, everybody clear how to get this? And now, okay, we're going to go back and finish that up, and we're going to get x to the fourth plus 6x squared plus 9 dx. And so now the negative is going to distribute there. So the x to the fourths are going to cancel. I'm going to get negative 16x squared, and 25 minus 9 is positive 16. And now I'm going to evaluate each of those. I get negative 16 thirds x cubed plus 16x from negative 1 to 1. And so I get pi times negative 16 thirds. If I just plug 1 in, I get that. Plus 16, and then
Take out the 16 before.
What did I do?
Like, could we take out the 16 before we do the roll?
Yeah, you could factor the 16 out here. Does that make sense? Okay.
Yeah.
Yeah, you can. And then minus, this will be positive 16 thirds because it's negative 1 to the third, minus 16. And then, man, what is that? Negative 32 thirds plus 32 times pi. And so that's, I think, going to be 64 thirds pi. And forgive me if I did something in my head wrong, but I think that's right. All right. All right. Any questions on that problem, on how to set that one up, or how I evaluated that, or did I add a fraction wrong? Definitely possible. But I think I'm good. Okay. Yeah, no problem, no problem. Okay, now we've got a couple questions in the chat. Somebody wants to do one in terms of y, which I think is a good idea. Let's do one like that. Okay, so did I miss a negative somewhere? If I missed a negative, then okay, go back and fix me. But this is the idea, and I'm sorry, it's just because I'm working fast. Okay, so if we had, yeah. So actually, why don't we use Jordan's region for y? Okay, so you're saying I missed a negative on 16 thirds right here? That's actually right, because, well, but it's negative 16 thirds times negative 1 to the third. So I'm pretty sure this is actually right on this one. You're okay. Yeah, I'm pretty sure I'm right. But if I did miss something small, then okay, double check me. Yeah, so okay, let's go through this dy region that somebody asked about in the chat. We'll use that one, and we will do a dishwasher and a shell for that one. And then if we want to do a shell for this one, we can come back to that, okay? All right, so the one in the chat is we have x squared. Okay, the region bounded by x plus y squared equals 24, and x minus y squared equals 6. This seems like one off one of my old exams, probably, so good. Okay, so to graph those, you should probably solve for x because of the y squareds. So like if I have x equals 24, or I'm going to solve that and get 24 minus y squared, I'm going to get this x equals y squared plus 6. Okay, so x equals y squared is a parabola that opens to the right. Negative y squared flips it around and makes it open to the left. And then the 24 shifts it to the right 24. So it looks about like that. And then y squared plus 6 looks about like that. And so, man, this should probably be symmetric, and it's not perfect for sure. That's a decent diagram. This is going to be 24. This is going to be 6. We need to get the intersection points. So I'm going to set 24 minus y squared equal to y squared plus 6. Going to add the y squared to both sides. I'm going to subtract 6. I'm going to divide by 2 and get y equals plus or minus 3. And so then the y values are 3 and negative 3. And so then the x values you can get by plugging in to this. 3 squared and negative 3 squared is 9. 24 minus 9 is 15. And so we've got that diagram. Again, it's not perfectly to scale. It's for sure more symmetric than that, but it will work. And then you want to pick a rectangle that represents the entire region. And so if you go up and down, that's not a good choice because the top boundary changes partway through the region. So like the top over here would be different from the top over here, and same with the bottom. So we're going to choose to go left to right. And the reason we want to do that is because now the left boundary is the same everywhere, and the right boundary is the same everywhere. So no matter, even if I draw it way down here, the left boundary is still this parabola, the right boundary is still this parabola, which means everything's going to be dy. dy means everything should be solved for x, which we've already done just to make the equations easier to graph. But we're going to use this version and this version of the equation. So this formula we're going to think of as, or this graph we're going to think of as x equals 24 minus y squared. And this one we're going to think of as x equals y squared plus 6. And so all of that's based just on that region. And now we're going to set up integrals to revolve around various lines. But any questions on getting that set up? Okay, so now let's revolve first. And we'll just do the setup, but we could for sure evaluate it if we want to. So let's revolve it about x equals 2. Okay. And so x equals 2 is a vertical line somewhere in there. What's important is that it's vertical and it's to the left of the region. And so this rectangle we think of as being perpendicular to this, which means we should use, okay, so we should use the dishwasher method. The question Gavin's asking is, will we ever have to evaluate or rotate around the line with a slope? Only horizontal vertical lines for our class. We would have to do a lot of weird stuff and like rotate axes to figure out how to do that, and I don't want to. Is that fair? All right, that's hard. Good question though, Gavin. We'd have to figure out how to do that, but we could do it. It's just we're not going to do that in here. All right. The question is, will we ever encounter a line that intersects our region? You will not encounter one that goes through the middle of the region, okay? But it might hit the edge of the region. So like x equals 6 would be exactly the same as what we're about to do. And x equals 24 would be fine. Y equals 3 would be fine. Y equals -3 would be fine. But y equals -1 would not be okay for our exam. Does that make sense? So if it hits on the boundary, that's okay. If it goes down through the region, that's not something you're going to have to worry about. All right. All right. So about x equals 2. So we're going to look for a large r and a small r. But those are functions of y because we're using dy. And so now it's still, so the question was, how do you know which is top and bottom? Well, none of them are top and bottom, not on this. And so what happens is you're looking for distances that are sideways. So the big R is still the distance from the farther end of the rectangle to that line. Well, if you look at this line, the farther end of the rectangle happens to be this. So we're looking for the distance from here to here. Well, that's a horizontal distance. Well, you don't subtract top minus bottom to do that. What you do is you take the x on the right minus the x on the left. Well, the x on the right is 24 minus y squared. The x on the left is 2. Does that make sense to everybody? Good. That then simplifies to -y squared plus 22. And that's the big R for this region. Small r, let's go with green, is the distance from the closer end of the rectangle to the line. Well, this end happens to be closer. But again, it's right minus left, not top minus bottom. So we're taking the right x minus the left x. Well, the x here has to be in terms of y because it's dy. So it's y squared plus 6 minus 2. So the right x is y squared minus 6. The left x is 2. We subtract those and we get y squared plus 4. Does that make sense? Everybody good? All right, and so the volume then is pi big R squared minus little r squared. So negative y squared plus 22 squared minus y squared plus 4 squared times the thickness dy. And now we want to add for all of the y's within the region. Well, the bottom y is negative 3, top y is positive 3. So we go from negative 3 to 3. Now that's still dishwasher method, and let's do a shell method next. But is everybody clear on that problem? All right, any questions? Could be in the chat, or you can unmute yourself, that's fine. All right. Oh, yeah, no problem, no problem. Okay, so now let's do a shell method. And so shell method, if we think of this, is everybody comfortable thinking of this as a horizontal rectangle? All right, so that doesn't really mean anything if you think about it, but we'll call it a horizontal rectangle. And shell method is when the rectangle is parallel to the line. And so we need a horizontal line. So let's put one above the region that we're going to do. So let's get rid of these. All right. And so horizontal line above the region, let's revolve about, and it could be below the region too, y equals 6. So now it's parallel. Well, when we use the shell method, the formula is 2 pi integral RH and then dx or dy. In this case, it's dy. And so we're using r of y and h of y. And now we want to look at what those are. So r this time is the distance from the line to the rectangle. And there's only one of those because they're parallel. So in this case, that again is a vertical distance. So here you do take top minus bottom. But the top y is 6. The bottom y is just y. So we go r is 6 minus y, and that's it. You don't use these equations because these are telling you what x is, and we want to know what y is. So r of y is 6 minus y. If this was y equals 30, it'd be 30 minus y. If it was down here, if it was y equals negative 7, it'd be y minus negative 7. Does that make sense? Okay. And so now h of y, it's weird to talk about height as being sideways, but it's the height of the rectangle. The base of the rectangle is dy. So the height of the rectangle is actually the distance from there to there, from the left end to the right end. Again, that's horizontal. So you take the x on the right minus the x on the left. Faisal, I'm going to answer your question next. You're right. That's a good question. Okay, but the x on the right minus the x on the left. So we would go 24 minus y squared minus y squared plus 6, which is negative 2y squared plus 18. And so then the volume is 2 pi integral r times h times the thickness dy. And we add for every y in the region, which is negative 3 to 3. Questions on that setup? Okay. Okay, so one of the questions in chat is what if it was y equals 3? So we're going to do that in this loud pink color so we can see the change. So y equals 3 would be like, oops. Let's get rid of some of this. All right, so y equals 3 would be like right here. Whoops. Does not go through the region, just hits in that one point. And so the only thing that would change is we would do 3 minus y right here. And it wouldn't matter, because remember, Faisal, when you were doing that very, very first worksheet and we did it like for numbers, and I would say like, okay, x is like 2.4, and then x is 5, and x is 1.7, and you had to calculate it for all those values? You know what I'm talking about? Okay, so what the integral is doing is it's giving you, or it's calculating this for every y value between -3 and 3. So like if you're talking about the rectangle down here, where this is y equals -1.7 or something like that, then the distance from this rectangle, -1.7, to this line, which is 3, would be 3 minus -1.7. Does that make sense? But then this one value up here where it's right at 3, well, the distance should be 0. And this formula is going to give you 3 minus 3, which is 0. So it works fine. Does that make sense? So that's why if it hits on the edge of the region, it's fine. If it goes through the region, that messes everything up. But if it goes on the edge or on the boundary, that's okay, and nothing really changes. Somebody asked, are we going to post this recording? I am going to post this recording. I'm going to try to do that tonight. But Zoom takes a while to process recordings, and YouTube also takes a while to process recordings. So there are 2 steps of processing I have to wait for. And so if we finish at 9:30, as long as Zoom is done processing by 11 or 11:30, I will start the processing on YouTube. That's fine. But it takes about an hour or so. So it's going to be real late tonight, like early tomorrow morning, like 2 a.m. And if it's not by 2 a.m., I'm going to bed, and then it will be tomorrow, like around noon. Okay? Sorry. I will try to get it by 2 a.m., but I'm willing to do a lot for you guys to help you ready, but I'm not willing to stay up past 2 a.m. Fair enough. Not tonight. All right. All right, but I'm trying. It just depends on how quickly it gets me the thing. All right. Other questions about this? Does this make sense? You can ask questions not about this too. It doesn't matter. But specifically, do we have anything about this? All right, cool. And the person who was asking for the shell method, is this good, or would we like to do a shell method for the dx one as well? I don't know who asked that. But. All right. Then I'm going to move on. I think that covers pretty much area. Well, it doesn't cover area, but it covers volume pretty well, except maybe the cross-section stuff. It covers that pretty well. Other stuff. What you guys got? Go ahead.
Hi. Could you do the bonus problem from the fall 2018 exam?
Maybe. Let me see what that bonus problem is and see
it
if
has to do with evaluating integrals, or without evaluating integrals to prove through volume.
Okay. Let me at least talk about it. I bet I know what you're talking about. What is it? What semester? Sorry. Fall?
It's fall 2018, I believe.
Okay, yeah. So let me pull that one up. Sorry, I'm not like looking in the sky. This is my other monitor. Fall 2018. That seems like a question I would have written. Yeah, okay. Exam 1, right? Yeah.
Yeah.
Yeah, okay. So without evaluating, it's a really good problem. All right, prove the integral 1 to e squared of natural log x squared dx is equal to 2 integral 0 to 2 of y times e squared minus e to the y. All right, now there was a reason this was bonus. It said hint, use an argument involving volume. So you had to prove that these two were equal without actually evaluating them. And so if you notice, like, if there was a pi here and there was a 2 pi here, this is kind of like shell method and this is kind of like dishwasher method. And you had to figure out what region this was describing the volume of. And yes, 1C, oh, I see a couple problems on the chat and I'll get to those next. So basically, y equals log x looks like this, where that's at 1. And so if you block this off at e squared, then this region that's bounded above the x-axis but under y equals log x and from 1 to e squared, this is the volume of that if you revolve it around the x-axis. Do you guys kind of see why that is? Like big R would be log x minus 0, small r would be 0 minus 0. So this, without the pi, if you put a pi on this, this is the volume when you revolve this around the x-axis. This is how to set it up with dy. And so if I set up a dy rectangle, we have to solve this for x. Well, it's x equals e to the y if you solve that. And so this equation's e to the y. So if I revolve again around the x-axis, r of y is y minus 0, which is y. H of y is right x minus left x, which is e squared minus e to the y. So if you throw pi's in here, this is the volume. Both of them are ways to calculate the volume when you revolve around the x-axis. And so you had to set that up, realize that this is the same as this, and explain why those are both that calculation. Again, there's a reason why it's bonus. It is worth thinking about stuff like that, but on an electronic test, you won't have to do something quite like that. But being able to go from dx to dy is something that is good to be able to do. And if you want to see the problem this is on my exam 1, fall 2018, the bonus question. And it said to prove that, and I think I didn't include that in the solutions probably, but that's what you had to do. All right. Okay, so we've got 2 questions. I'm going to see what fall 2019 exam 1C is, and then Lauren will do your question first, but if it's the same type as this question, we're going to do it at the same time. Let me pull it up though. Fall 2019, right? 1C is not the same. All right. Okay, so 1C is integration by parts. So you skip it because we have not covered that yet. That last fall, we gave the exam probably a week later. And so we had covered more than we had now. So we can skip that one. The one that Lauren's asking in chat is, can we do the integral of 7x squared over the square root of 25 minus 9x to the 6th? And so this is a good problem to look at. Not that the other one's not, it is a good problem to look at for parts, it's just we haven't covered that yet. And you all would have no way to know that yet by looking at that problem because we haven't talked about it at all. It's just none of the stuff we've done works on that problem, which good that you thought it was hard because you can't do it. All right, so now we look at this one, and there are 2 good options at first glance. We can either try to make it match that top form, or we can try to make it match the bottom form. And chances are that just in general, neither of them might work, but if one of them works, only one of them works. We need to pick one. Gavin, are you gonna have to complete the square? No, unless you choose to do a weird method that I hadn't intended. Does that make sense? I'm not intending for you to have to complete the square on this exam. But I do understand there are multiple approaches to problems. So if you come up with a weird solution, that's more on you than us. You don't need to complete the square. All right. Okay, so this problem, if this top form's easier, if you can use it. But the problem is you would need to equal this entire inside, and du then would be x to the 5th, which is going to be very difficult or impossible to get from this. Does that make sense? So this first setup doesn't work, but that should be the first thought. And then, okay, because that doesn't work, then we're going to attempt this. And it turns out it will work because we're able to mess with this 25, and we'll show how in just a second. But u ends up being whatever you square to get this, which is going to be some constant times x cubed. And so then the du is another constant times x squared, which is sitting on the top. Does that make sense? And so that's going to work. So we have to make it match 1 minus u squared. So I'm going to factor out the 7 over the square root of 25. And we get it to that. And while we're looking at that stuff, yeah. So for the completing the square comment in the chat, that is a legitimate thing that you may have to do on exam 2, but a lot of classes, including mine, will not cover that until we get to partial fractions, even though it's technically just U substitution. And so the fact that you've done completing the square is more than reasonable, and chances are there's a good possibility you will have to do that on exam 2. Just we have not covered it yet in all classes. Okay, so I don't think it's fair to put on this exam, but so we didn't because I wrote it. Sorry. So we're not doing it. All right. So anyway, now we're going to let U equal 3/5 x to the third. And the reason we're going to do that is because if we square 3/5 x to the third, we get 9/25 x to the 6th. So remember, this is U squared. So U is whatever you square to get this. All right, sounds good, Chris. No problem. I'll post this hopefully tonight, but if not by noon tomorrow. All right. All right, so we got 7/5 integral 1 over, well, just kidding. Sorry, I'm jumping ahead. We got to get du. Du is then 9/5 x squared dx. So now we've got 7/5 integral. I'm going to move the x squared off of the fraction and put it next to the dx. And simultaneously, I'm going to go ahead and multiply inside by 9/5 and outside by 5/9. Does that make sense? All right. And so now we've got 7/9 because those 5's cancel. Integral 1 over the square root of 1 minus u squared du. That is the antiderivative of that is inverse sine or arc sine of u plus c. And so then we get 7/9 inverse sine of 3x to the third over 5 plus c, and that's the answer. Questions on that? Tricky problem, but does everybody follow it?
Can you show how you went from 9/25 x to the 6th to get u to be 3/5 x to the third? I mean, I know the third and the 6th part, but the fraction.
Okay, just you're thinking, what do you square to get this? So like, what do you square to get 9? 3. And what do you square to get 25? 5.
Okay.
Does that make sense? And not because of the square root, but because this is u squared. So like, whatever u is, if you square the whole thing, you need to end up with that. Does that make sense?
Did you forget to carry like the 5/9 out front all the way down, or does that cancel out or something?
The 5's cancel.
Oh, okay. I see what you're saying.
So then I got 7/9.
Okay.
There's a lot going on, so completely fine. But you follow that?
Yeah.
Okay. All right. This is fair game for the exam. There's a whole worksheet on this called U sub 2. And you guys had a big WebAssign on that too. So the U sub 2 worksheet, there's probably like 20 of these. The inverse tangent and this. Not fair for me to tell you for sure whether it's on the exam, but it is fair game for the exam. Okay. All right. Other stuff. What else you guys got? Volume slicing problem. Yeah. You mean like where we say the cross section is a triangle or something like that, right? Is that what you're talking about, Tyler? Okay, yeah. All right, so let's say set up the integral. Of the solid whose base is the region bounded by y equals x squared plus 3 and y equals 19. Cross sections of the solid parallel to the y-axis are rectangles with height double the base in XY. All right, so we're going to set up the integral of the solid whose base is the region bounded by y equals x squared plus 3 and y equals 19. So this region in the xy plane. And so let's go ahead and draw that. So where does our work? So x squared plus 3 looks about like that. Y equals 19 is a horizontal line somewhere up here. So this is 19 and that's 3. And then we can quickly get the intersection points by setting x squared plus 3 equal to 19. So x is plus or minus 4. So this is 4 comma 19. And this is negative 4 comma 19. And normally I would tell you, okay, go ahead and draw the rectangle that you want. But in this case, the cross sections dictate the way you need the rectangle to go. And so the cross sections are parallel to the y-axis, which means your rectangle needs to be parallel to the y-axis. So it should go like that. Does that make sense? Okay, and so in yesterday's video, the one called More Volume, there's some pictures that I think are pretty good. Slicing problems are fair game for the test, yes. So same deal with, you know, the problem up above, that's fair game, so is this. May or may not be there, really can't tell you, sorry, but it is fair game. Average value, arc length are not fair game for the test, this is. Okay, so the idea is, there were some pictures yesterday though that would show like the triangles extending up out of the page. And so there the thing was a triangle, and I think there were some other ones where it was a rectangle. And so this though, I'm saying, okay, it's a rectangle that extends up out of the page. The base is in the page, it's right here, and the height of the rectangle is double that. And so the idea on these is the volume is the integral of the area of the cross section times either dx or dy, and in this case, dx. So it's the area of whatever the cross section was. And so the cross section is this rectangle. Well, the area of a rectangle is base times height. Colin, definition of slicing problems like this, we're describing the cross section rather than saying rotating it around the region. So we're like looking at this one cross section, but there's another one over here. And so it's like you're slicing it, like each of those is one of the slices. Does that make sense? Okay, all right, cool. But it's basically what we covered in lecture yesterday. And if you couldn't come yesterday, completely fine. But this is the video on it. It's a really short video. There's a whole handout on it, but there's a relatively short video on it. I think 20 minutes maybe, because we talked about the test for like half the class. All right, so anyway, the area of the rectangle is base times the height. Well, the base is oddly enough the height of this rectangle. So the base is right there. The height is coming up out of the page because it tells you the base is in the XY plane. Well, the height is double that, right? And so the base is the distance from here to here. So top y minus bottom y, well, that's 19 minus x squared plus 3, which is negative x squared plus 16. Remember, this is the y-axis, all right? The height is double that. So the height, and just because it says that, so height's double the base. So height is 2 times negative x squared plus 16, which is negative 2x squared plus 32. So then, okay, the volume is the integral of the base times the height times dx. And now we want to add it up for all the x's in the region. Well, the x's go from -4 to +4. No pi or anything, no 2 pi, because we're not using that. We're using length times width. The disk washer method is actually a special case of this, where the disk, the area of that is pi r squared, and that's where that formula comes from. We went through that one in detail, but this is kind of a generalization of that, where you can do it with anything. It doesn't have to be a circle. It can be a rectangle or triangle or whatever. You're doing the same thing. It's just not pi r squared anymore. Okay. Does that help with the question who was asked, or the person who was asking the question? Does that make sense, Tyler? I think. All right, cool. All right, questions on that? We're good?
It'd still be counted right if it was like I end up getting a definite integral from -4 to 4 of 2 times the base squared.
Yeah, sure.
Same thing.
Yeah, it understands that stuff on almost every problem. I think there's a couple where you type in just a number where it would not understand that, but on this type of thing it would. And then when you guys take the test, you're going to see, I think on Friday, you'll see your score, and you'll actually be able to go back and see like what you got right and wrong. And you can see what the answer was, and you can see what you put. If you think it's a typo, tell me, and we'll look at it. And like, or if you think it didn't understand it, like, the worst I'm going to say is, hey, no, you actually did do it wrong, and here's why. I'm never going to take like more points off. So like, you know, it's definitely to your benefit to come in and ask. And like I said, your score cannot go down. I'm not going to say, oh, sorry, you missed more points. But I might give points back. So like, you know, if it didn't count that for whatever reason, just let me know. Like I said, because there's 80 some people in the class, I'll probably say, hey, let's meet up on Zoom and we'll do it together. But like, I will definitely do that. Does that sound fair, everybody? Now, if you're not in my class, you do that with your instructor, not me, because I can't do 500 students. I can do my 80. All right. All right. Other questions? Other stuff?
I have some antiderivative problems.
Sure. Completely fine. Whoops.
I have 4, but I mean, we'll go one by one.
Yeah, do one of them.
If we don't get them all, then that's fine.
Yeah, we'll do what we have time for. Pick the one you want the most.
Sure. So the first one, it's an easy readout. It's the antiderivative of secant cubed x multiplied by tangent cubed x dx.
Okay. This one is beyond what we're going to do on this test. It's a type of problem called power of secant and tangent. It's actually a good problem. But we're going to go over specific strategies for this next week. Okay? It doesn't involve anything beyond what you guys already know, but we just haven't kind of solidified that yet. So
I think it popped up in one of the impromptu meetings or something, maybe with the TA, or maybe
it may very well have, and they may have pulled it from an old test and not realized that it wasn't on this exam.
Sure.
Okay, sorry about that.
No, that's fine. The next one is, I know that we've gone over it a million times, but it's just tangent x dx.
Tangent x dx, let's do it.
Yeah.
Okay. So earlier we did tangent squared, and we did something that was completely different from this. But on this one, what is a good idea is to rewrite it as sine over cosine. And so we're going to do a u substitution where u is cosine x. And you have to do it that way because remember, we have to get du. So like du is negative sine, and we're going to be able to get that because the sine's on the top. If we flip this, du would be cosine, but you can't get cosine over there. Cosine's in the bottom. You'd get 1 over cosine, which is not what you want. And so what you can do is you can split off the cos or the sine, and then you can put a negative here and a negative out here. And so we get it to there. Does that make sense to everybody? That's good. All right, and so then the antiderivative of 1 over u is log. And then u was cosine, so we get negative log absolute value cosine x plus c. And that is a good problem to make sure you know how to do. Everybody good doing that? All right, cool. Cotangent would be almost exactly the same. Does everybody see that? So like it'd be cosine over sine. You'd let u equal sine, and then you do pretty much the same thing. You would not end up with a negative in there. All right. And then you can keep going unless somebody else puts something in the chat.
Yeah. If somebody drops something in the chat, feel free to just drop me on these, and they've
Completely
got problems
fine.
too. The next one would be the integral, or sorry, the antiderivative of sine squared x dx.
Also too hard for now. Sorry.
Oh no, that's fine. I'd
That's the other next
rather
one.
not stress over these.
You're good. Some of the
stress over
old
other
exams,
ones
a couple years ago, we might have even switched the order of some stuff. So sorry about that.
Sure. My last question would be the antiderivative of x plus 1 times root 6 minus x dx.
Okay, is the x plus 1 in parentheses? Like that?
Yes, exactly like that.
Okay, cool. So all right, so this is a little weird problem. You almost have to see that we should probably try to do that because it's the square root of 6 minus x. And so like, we're gonna let u equal that, and then du is -1 dx. And now it's not obvious why this makes it a lot easier, but we can get the -1 dx by just multiplying by a negative outside. Does that make sense to everybody? Okay. And so now the 6 minus x, we can replace that part with u, but the x plus 1, we need to solve this for x. So if u is 6 minus x, x plus u is 6, and then x is -u plus 6. So I can rewrite this as -u plus 6 plus 1, square root of u du, which is real weird, but does everybody follow that? The reason that makes it easier is because we can mess with this algebraically, whereas with this subtraction in there, we can't. And so I'm going to go ahead and make it -u plus 7, and then make this u to the 1/2, and now we're going to distribute the u to the 1/2. And now this gets split into 2 integrals. And now it's power rule. So we get to that. Everybody follow that? And Colin, I see a question in the chat. Yes, we will do that next. All right, any questions? We're good? And what do we mean by involves polynomial? Just like a polynomial over a polynomial? Madeline, we do need to keep the negative, but it cancels. So it's negative on this, like the negative distributes. So negative there gets us plus, and then -7 on that one. Does that make sense? Okay, yeah, no problem. No problem. A tough one of some sort? Okay, well, these get tougher. The question is, can we do one where it's a polynomial over a polynomial? And the times they're tougher are when u sub doesn't work. And that's what we haven't covered yet. So like the toughest thing we've done like that is if I'm doing like 0 to 1 of x plus 3 over, say, 9x squared plus 16. And so this one's actually kind of awful. And the reason it's kind of awful is because this, if you let u equal the bottom, du is 18x, which would be great if it was just x on the top, but the 3 messes with that. And then if you try to use inverse tangent, u is the square root of this term after you remove the 16. So u ends up being x to the first, and du is just a constant, which is great if you had the 3 but not the x. So what you do is you split it into 2 and do both log and inverse tangent. And so I would for sure, on one this complicated, drop the 0 and 1 and go over to the side and split this up and do all the work over here, because this is the hard part. So we're going to split this into 2 integrals, and we're going to make it x over 9x squared plus 16 plus 3 over 9x squared plus 16 dx. And on the first integral, we're going to say, okay, u is 9x squared plus 16. So du is 18x dx. And that's easy to get on the first integral. So we've got 1 over 9x squared plus 16. We have an x there. We're going to put 18 in. So 1 over 18 outside. The second integral, that doesn't work. So we're going to try to match the form 1 over 1 plus u squared is the goal. And so we need a 1 there. It's kind of like that inverse sine one we did. So you pull out the 16 to force that to be a 1. And we get it to be like that. Does that make sense to everybody? That's good. Okay, only because I used the letter U already, we're going to pick the letter V, and on this problem, we're going to let V equal 3/4 x to the first, and that's the exact same thought process as that inverse sine one. I need this to be U squared. So U is whatever you square to get this. Well, 3 squared is 9, 4 squared is 16, and x squared is x squared. And so then dv is 3/4 dx. And so now, okay, the first one is actually pretty straightforward. We've got 1/8 times the integral 1 over u du. The second one, we need a 3/4 inside. So we've got this 1 over 1 plus 9/16 x squared times 3/4 dx. That means we need a 4/3 outside.
Ah! Oh my god!
All good?
Jesus both parties okay.
My laptop.
I think he doesn't know. He's not muted.
I hear that. I'm sorry.
Okay, it's fine.
I'm trying to find mute all and I can't find it.
I was like,
There we go. All right, thank you. All right, so we got 1/18, and this is log absolute value of u. And then over here, we've got the 3's canceling, and 4 over 16 is 1 over 4. And now we got 1 over 1 plus u squared du. And now that's 1/18 log absolute value of u, but u is 9x squared plus 16 plus 1/4 inverse tangent of v. My bad, those are v's. Let's make this all blue. Not bad. Yeah. And v though was 3x over 4. I'm skipping one step there, but we get that. Does that make sense so far? Okay, and so now back over with the original problem, we've now got, okay, 1/18 log of the absolute value of 9x squared plus 16 plus 1/4 inverse tangent of 3x over 4, evaluated from 0 to 1. And so now you plug those in. And so that's what you get when you plug 1 in, and then you plug in 0, and you get 1/18 log of 16 plus 0. Inverse tangent of 0 is 0. Those other ones you can't simplify using trig, and so you leave those other than just, I guess you can do, actually, 1/18 log 16 cancel out? I guess it does. Sorry, so my bad. Those cancel. So you get 1/4 inverse tangent of 3/4. Oh, that's not 16. That's why. My bad. So that shouldn't happen. This is 25. So, okay, so you get this. And you can drop the plus 0, but there's nothing else you can do to simplify that, really. Does that make sense? That's a lot, but that was what you were asking, something hard. It's hard. You're welcome. All right. You guys good with that? All right. All right. Might have time for one more. Anybody have one? Okay. Oh, do something really hard. We just did, Andrew. That one was tough. That was tough. That was not easy. That was tough. I tell you what, I'm going to pull up an old exam, and I'm going to let you tell me what's hard. Give me a second. All right, let's go in here. All right, you guys seeing these old exams now? Yep. Okay, let me find, I think this semester was probably pretty much, yeah, okay. Okay, easy. Does thumbs up or something if you're sharing your screen. Easy, hope that was easy. All right. That we don't know how to do yet, that's parts. My bad. Okay. We do know how to do that. Any ideas? No idea? Oh, Emily, I saw your question. We'll
The U sub of ln x.
We do U sub. Yeah, okay. Yeah, U equals log x. All right, let me write it down and we will do that one in just a second. And then if we have time, we'll do another cylindrical shell. But yeah, U is log x is a good way to start that problem, and then let's talk more about it. Okay, that one. Couple ways to go about it.
Could you split it up into two integrals?
That is what I would do. I would split it up into 5 over x plus log x over x. And log x over x is like a quick U substitution. Does that make sense? Okay. Or you could let U equal the entire top and du is the bottom, or 1 over x. And so either way, and then you got to go in and plug in 1 over 1 and e. Okay. That one should be easy. Is that true? Should be easy, I hope. That one is like the one we just did, where you have to make it into inverse tangent, but you don't have log and inverse tangent. You just have inverse tangent. Type equation here. Okay, I don't know why it says that. There's the volume. That region looks okay. This, I think, is the region we just did, or awfully close. And that is, I'm going to say, not worried about right now. And these are some more area volume. And that was about it. That was my exam 2 years ago on the same basic material, except I guess we had started integration by parts. All right. Okay, so let's do that one. And then Emily, we did cylindrical shells back up here. I think we're not going to have time to do another. This is cylindrical shells when we're doing the 2 pi RH. And so if you were here during that, that is what cylindrical shells is. If you weren't here, I'm going to upload the video of this as soon as it's possible, and then you can go back and watch that. But we did do one that was cylindrical shells. You're completely fine, just because we are going to try to get out here by 9:30. We're not going to have time, but I will post the video. It may be real late tonight, or it may be tomorrow morning. Just depends on how long the processing takes. But I will post the video. The goal's tonight, but at worst by tomorrow at noon. All right. So this is the problem. Man, let me share that so you guys can actually see it. I wasn't sharing what I was just talking to you about, but we did do it earlier, and we will do that. You can watch that video. All right. So anyway, so here you let u equal log x. Du then is 1 over x dx. Well, that part's relatively straightforward. So we get 1 over cosine squared of u du. And now we got to figure out what to do with that. What do you do with that? What do you guys think? You may get something like this one. So what would you get? Or here in an hour and a half, 2 hours and a half. Yeah, make it secant squared. 1 over cosine is secant. So 1 over cosine squared is secant squared of u. So there's one involving a trig identity. Then it's easy. But you had to notice that. Does that make sense? Everybody good? Okay. Well, you guys, thank you for coming to the review. Good luck on the test. You are welcome to start it at 12:01 a.m. if you want to. I don't know that that's what I would recommend, but it's your call. Definitely start by 10 p.m. just to allow enough time if you have a technical issue or something like that. But you get 90 minutes when you start, and then you got 90 minutes and you're done after that. So good luck. I hope it goes well. If I don't see you, have a good weekend, and hopefully I'll see you guys Monday. Thanks, guys.
I'm sorry, I actually had